Let's continue our conversation about functions. We've got some more key terms to look at. So the first one, the domain is the set of all first coordinates. The range is the set of all second coordinates. A set of ordered pairs is called a relation. And when a set of ordered pairs is such that no two different pairs share a common first coordinate, we have a function. Should sound familiar because we just got done discussing that in the previous lesson. I just want to show you too the domain when it says the set of first coordinates, that's traditionally our x coordinates. And our second coordinates, just think of that as all of your y coordinates. So when we look at this particular problem, it says determine for each one f of 1. So that's the first thing we're going to have to find is f of 1. In other words, when our input is 1. So when our x equals 1, they want to know what does y equal. That's what they're asking in that first one. So if I look for x equals 1, it looks like when x equals 1 and I go to my graph, that's this point right here. That has an x coordinate of 1 and my y coordinate appears to be -3. Part B, the domain. They want to know the domain. So the domain is all of your x coordinates, or another way to think of that is how wide is your graph. So the width of the graph. So if we look, it starts all the way on the left-hand side. It starts at -2. So all of my x coordinates fall between -2 and it looks like 5. In other words, we have to be less than or equal to 5, but greater than or equal to -2. So this is what the domain would be. That's your width. And that's because the width of your graph is your x coordinates. C says any x values for which f of x equals 2. So this one is the opposite of the first part. We don't know the input, we don't know the x, but we know that the output, or the y value, is 2. So now go to your graph. And where does the y equal 2? Well, here's y 2, so this point right here has a y coordinate of 2. What's the x that goes with it? -1. So our input value would be -1. Because they just want to know any x values. So x would be -1. You could put x equals there if that makes you feel better. And finally, D, the range. Now, if the domain is the width, then the range has to be the height, or how tall, or the length, or however you want to think of that. I usually think of it in terms of height. So the lowest my graph appears to go on the y-axis is -3. The highest it appears to go is 2. So my x is in between -3 and 2. So I have to be less than or equal to, oops, and that's a positive 2. Okay, just wanted to make sure. I have to be less than or equal to 2, and at the same time greater than or equal to -3. So you really have to watch your terminology and your vocabulary on these problems. Now on this, find the domain. Okay, in the previous problem I had a graph and I could tell how wide my graph was. When you're asked to find the domain and you're given a function, remember domain are x values. We typically take x values and we plug them in and we get a y value or an output. And you might think, well, we can plug any number in. And that's true, but not so true in some cases. For instance, in number 9 here, sure, I could plug in any number that I want and I'm going to get an output value. So for this one, we'll say the domain is all real numbers, because I can put any number in and I'm going to get a number out. Same is true for number 10. I can put any number and multiply it by 4/5 and I'm going to get another number. Yeah, I'll get a decimal or a fraction, but I'll still get an answer. What you have to look out for are those situations where, like number 8, we have a variable in a denominator, and you have to be careful with fractions, because remember there's that one rule that says you can't divide by 0. So a number over 0 is undefined. So we can plug in any number we want except any number that will create a 0 in the denominator. So what we have to do is look at our denominator if we're given a fraction and ask ourselves, what value creates 0? Because whatever it is, we have to eliminate it from the numbers that we could possibly plug in. If I just solve this little mini equation, and you can already tell me the answer, I'm sure. If x equals 1, if I plug in 1 in my domain, or in my denominator, I get 1 minus 1 is 0. I get 7 over 0. That's undefined. So I can put in any number I want except the number 1. So we can say, there's a couple different ways we can say this. We can say all real numbers except -1. I'm sorry, not -1, +1. There's other ways to write it too. It just depends on what MyMathLab is asking you for. If they want something called interval notation, then I can show you how to do that as well. But I think for this, they just want to know, they'll just have you put in the number 1 for that. So all real numbers except x cannot equal -1.